Hey friends, today we're going to talk about the midpoint and distance formulas. All right, so here in section 8.1, we have a concept of the midpoint. So if you have, this always looks really generic and a whole lot of stuff going on, but if you have 2 points, right? And so we're using the generic x sub 1, y sub 1, x sub 2, y sub 2. So when I feel confused, sometimes I just use numbers, right? So let's say 1, 3, and then let's say that number is 1, 3, right? So if that's the case, that would be 1 there and then 3 here. And then let's say this number is, or this point rather, is point, I don't know, 5, 5. No, yeah, whatever. Let's not do 5, 5. Let's do 5, 4. Okay. All right. So I know that these aren't the best markings, but sometimes it just helps to do this. So think about it this way. If I want to find this orange point here, the midpoint, you know there's a couple things that's going to go on. The midpoint of the x term of that midpoint, the x term has to be midway between the two x terms that I have. So if I have a 5 here and a 1 here, I can find the average of those two. 5 plus 1 is 6. Half of that is 3. That gives me the middle of these 2 points, right? So that's what I have here. And I'm going to do the same thing here. The middle of these 2 points, to find the y term, the middle of these 2 points would be 3.5. So to find the midpoint, we take, how do I get the 3.5? We add the 4 and the 3, divide by 2. So to get the midpoint of any 2 points, you take the average of the x terms and then the average of the y terms. And then hopefully that feels like it makes sense, and the generic stuff makes sense too. Probably would have made more sense if I didn't make my example, but let's go ahead and see how we can find that information. So here we have a landscape drawn on a grid, and it says that the landscape includes 2 flower beds and a sprinkler halfway between them. Find the coordinates of the sprinkler if the origin of is at the lower end of the corner. So what they're basically saying is that we can kind of treat this as an x and y axis, right? And if we do that, we need to think of the numerical values along each axis. So we have these markings here that kind of indicates the numerical values as we go across. So we know that let's see, if we want the sprinkler to be between the 2 flower beds, we want it to be right between these 2 guys. So I'm going to call this like the middle of the flower bed is right here at 4, 5, right? 4, 5. And the middle of this flower bed is right here at 14, 14. And so what I need to do is find the midpoint between those 2 points, and then that's going to give me the answer that I need. And you remember, to find the midpoint, it really is just finding the average of the x terms and the average of the y terms. So sometimes I'll write the formula like this, not like that because that's wrong. The average of the x terms, x sub 1 plus x sub 2 divided by 2, and y sub 1 plus y sub 2 divided by 2. And so that's not too bad, right? So we have 4 plus 14, those are the x terms divided by 2, and then 5 plus 14, those are the y terms divided by 2. And what I end up getting as a result will be 9, and this will end up being what, 9.5? And so that would be, so let's find it, 9 and 9.5 is about right here. So this is where I need to find I need to put my sprinkler system. Make sense? I hope it does. All right, guys. This next concept, referred to as the distance formula, is I don't have it here, it's formula though. The next concept, referred to as the distance formula, is pretty cool because it comes from the Pythagorean theorem. So if you haven't seen the Pythagorean theorem in a long time, let me remind you of what it is. Walking down the street, if you have a right triangle, you know that the sides all relate in a very special way. The longest side is called the hypotenuse, and we usually refer to it as C. The other 2 sides are called A and B, or usually referred to as A and B. And these sides will relate in this way. A squared plus B squared will always equal C squared anytime you have a right triangle. So if have a square or a rectangle, let's do a rectangle, and you know the length of this side and maybe the length of this side, you can find the length of the diagonal by using the Pythagorean theorem. A squared plus b squared equals c squared. And in that case, I'd put 4, I'd put 7, and then I'd calculate c squared, okay? All right, so that is just a quick reminder of what that is. And we also know that if I were, just a real quick, if I were to tell you that the diagonal was like, I don't know, 10, you can calculate the value here. It wouldn't be 4, but you can calculate the value there. All right, so with that kind of reminder of what the Pythagorean theorem is, we're going to talk about the distance formula in a very simple way. If I had 2 points, I want 2 random points that are the endpoints of a segment, what I would do to find that is use this formula. But where does the formula come from? And this is how the Pythagorean theorem comes into play. The Pythagorean theorem can give me information about the lengths of the sides of a right triangle. So if I impose a right triangle here, where the length of the segment will be the hypotenuse, this would be my C. I'm going to call it D since we're using the distance here. This would be, let's say, my A value, and this would be my B value. How do I get my A value, though? How do I get the distance from here to here? This distance will be the distance from x1 to x2. So A is equal to the distance between x1 and x2, which is x sub 2 minus x sub 1. B, this height, will be the difference between y sub 1 and y sub 2. Like y sub 1 would be here, y sub 2 would be up here. The height of this triangle would be the difference between the two. So we get y sub 2 minus y sub 1. And then if I'm going to apply the Pythagorean theorem just to the green stuff, remember the Pythagorean theorem is a squared plus b squared equals c squared. But in this case, I'm talking a squared plus b squared is equal to d squared. And I'm going to replace that with x sub 2 minus x sub 1 quantity squared. That's my a value squared. And then my b value is y sub 2 minus y sub 1 quantity squared is equal to d squared. You guys are seeing it, aren't you? If I take the square root of both sides, I get that d is equal to the square root of x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared. And that's where we get this from. So it is a direct outpouring from the ideas around, or from Pythagorean theorem. That's where it comes from. So do I want you to be able to do this? Yes. Am I going to ask you about it on a test? Probably not, but you never know. But what I am going to ask you to do is definitely have this memorized, right? You should know how to use the distance formula. So given 2 points, if you find the difference between the x point, square it, and add that to the difference between the y coordinates value, and square it, then you take the square root of that, you've got the distance between the 2 points. All right, so let's go ahead and see how we can apply the distance formula here. Distance formula, writing it down because I memorized it like you have. So x sub 2 minus x sub 1 quantity squared plus y sub 2 minus y sub 1 quantity squared is what we're going to work on. So to find that distance, my x terms, it doesn't really matter which one is your x term, x sub 2 and x sub 1. And honestly, unlike when we're finding the slope, it kind of doesn't matter because we're going to square it. So even if I did it in the wrong direction, squaring it would kind of take care of any issues. Think about it for a second. It'll make sense. But for the point of being a good teacher, I'm going to call this x sub 2, and this will be x sub 1, and therefore this is y sub 2, and this is y sub 1. All right, so 4 minus a minus 3 quantity squared plus negative 4 minus 6 quantity squared is going to be all that we need to calculate, well, and then the square root of that to get our answer. So this becomes 7 squared, which is 49, and this becomes negative 10 squared, which is a positive 100. And then so my answer is going to be the square root of 149, and with a little bit of calculator intervention, I can leave it like that, or I can find the approximate value, the approximate distance, and I get approximately 12.20 units, something like that, 12.2. All right. This final example is a multiple choice one where you're asked to figure out which point is furthest from this point here. And I'll be honest with you, I would probably be tempted to draw the picture and just kind of give it an eyeball answer if I were taking a standardized test, but we can also figure out how to do that by figuring out the distance between each of these points and this point and each of the other points. So we're going to do the distance formula for practice. Recalling what the distance formula is, I'm going to populate each of these distances to represent each of the number choices that we're talking about. So this will be the distance from this point to 2, 4, so forth and so on. And so we'll see that. So I set up each of the situations that I needed. So -1 minus 2, 3 minus 4 quantity squared, -1 plus 4, because that's a minus 4, and 3 minus 1. And you can check the rest of them, -1. So now all I'm going to do is calculate these values. So you'll notice that I just simplified underneath the radical, and after doing that, you can clearly see which one is the furthest. It would be D. It would be this figure here. And I don't know, maybe if we graphed it, we would have seen it faster. I'm not sure, but just for the sake of knowing what you know, and not depending on a terrible graph, this is what we can do. And I think that's it. The next section, we'll talk about parabolas in a different way. But until then, let me know if you have any questions, concerns, or problems. Look forward to talking to you soon. Bye-bye.